Hello everyone. In this session, we are going to discuss about the fifth exercise of the DLT, Deep Learning Techniques paper. So the problem statement is design and implement to classify the 32 by 32 images using MLP, multi-layer perceptron, using the TensorFlow or Keras, and check the accuracy. So in general, whenever the image classification is, generally we will go with the CNN concept, but you need not go for CNN concept for all the image classifications. You can classify the images by using the basic logistic regression also, and you can use the SVM, you can use the decision tree, anything, any classification algorithms you can use for, you can use the any classification algorithms for the classification of the images. But if the image is more complex, then you should go for the CNN. So here we are going to take the examples. Here the original data set is available in the Kaggle, and the data set was provided in the Google Drive in this link. This is the data set given, DLT Lab 5 folder, and inside that there are various files available. So see here, you can observe that the images of the fingers, shown fingers, this is the 4 and 5, 3, 2, like this. There are the images specified. This is the 0, and you can observe that the file name is the, in the file name last character is the label. See here 4, and this is the 5, and this is the 3, and this is the 2. So 2, this is the label. So we have to capture the file name, last character of the file name apart from the extension, and we have to take that as the label. So this is the simple logic for that, and already we discussed in the lab 4 how to access all these files in our notebook. We have discussed, so you can go through that for clarification. So we can access all the files as we discussed in the DLT4. So the data set is having total 12,000 images, but we have reduced them number of images, and the problem statement is we have to fit a classification model to predict the number shown with the hand gesture in the given data set and to check the accuracy, and we have to design the ANN model and train it. We have to check the accuracy for test data also. So let us go with this. So we are importing the libraries, required libraries, NumPy, Pandas, and here we have to use the PIL and also Matplotlib, and image handling video is also available. Previously we have released that. So in that, how to handle the image and how to create the data set with the image, so that was discussed in the video. You can go through that and see here. This is the, for sample we are displaying the one image. So, and then we have to load the data set. We are defining one method, load imgs method, by taking the path of the directory as the input, and we are defining this method, and here we are using the ANN. For the artificial neural network, we have to provide the data in the one dimension, meaning that you have to give in the single row. Actually the image is representing with the 2 dimension, but we have to make it flatten so that it will be given in the one dimensional array that should be given as the input. So 32 by 32 image can be represented with 1024 pixels, so that 1024 attributes are the inputs, and the label will be already taken as the last character of the file. So the representation of the row, representation of the image in the row, first image representation in the array format, one dimension array format, and the corresponding label, and second row represents the second image with the single dimension array and the label. So in this way all the images are taken. Now I am calling these method, I'm trying to execute all of them here. So we have to mount the data set, connect to drive and my drive and continue. I want to give the access so that it will be mounted. After mounting the drive, I can access the data from the So now I'm importing all these libraries and let us execute all of them. Now I want to load the images imgs and labels equal to load imgs of DLT5. From that I am taking all the images will be taken. It is reading the images. It may take some time because it has to load all the images. The actual dataset is having 12,000 images, but in the reduced images we are having around 3,000 images. So it is taking time to load those images. So the images are loaded. Now I want to display what is the shape of the dataset retrieved. That is 2,988 images are there, and each image is 1024 because we are resizing with 32 by 32 and flattening also, and we are extracting the last character from each file name. J represents the file name. So J dot split off dot and last character we are taking, and then I want to display the labels also. We are getting the labels, and then train test splitting the data into train and test data sets. Now I am applying the logistic regression. See, here we have a simple table. The table is 2390 90 records and 1024 columns. That is the table, and the target is 2390 records. So these are the we can fit the logistic regression easily. So I am trying to fit the logistic regression on this, and then fit the model. Then I want to check the accuracy also. So it will take some time for fitting the model, train the model. So logistic regression is fitted, and now I want to check the accuracy, test accuracy. Test accuracy is 99%. You can observe that with the logistic regression only we are getting the 99%. Why should we go for ANN? Okay, for the complex problems we have to go for the ANN. So it is very simple example. So logistic regression also we can solve, but as given in the problem statement, we have to go for the ANN. So in this, I am fitting the, I am designing the model. I am taking the sequential model and a dense layer, and then we are taking the sequential model equal to sequential, and the model dot add of dense we are taking, and 16 units. I am taking with 16 units, and I am going with the single hidden layer only with the 16 units, and activation is ReLU I am taking, and the output layer is 6. Here also 6 because we are having only 6 labels: 0, 1, 2, 3, 4, 5. So total 6 labels are there. So dense of 6, activation is softmax, and I want to compile the model with a sparse categorical cross entropy, and the optimizer is Adam I am using, and then we are going with the metrics or accuracy. I want to see the metrics for accuracy for every epoch, and I am displaying the summary of the model, and then fit the model. So we can fit the model with the 25 epochs. I am training the model so that it is getting trained. So with 25 epochs it is giving 100% accuracy, and test accuracy we have to go to check the test accuracy. It is also 99%. So it is very good model. So I need not increase any layers. Actually, if you are getting if your training is not performing well, you may get here after 25 epochs also, if you get only 0.5, 0.1 only, it is getting stuck. Then you should increase the model complexity. You may increase the model complexity. That is by adding the layers, by adding the units. You can add anything. See here, in this example only. See here, I have commented this. You can remove that comment and execute it, so that we can add the one more dense layer. How many dense layers you want? You can use any number of dense layers, any number of. There is no restriction for the architecture, meaning that the network architecture. You can add any number of layers. There is no thumb rule for fixing that. So in future you will have some exercise. Standard architectures are there that we will discuss in the coming exercises. And then we are fitting the model. After fitting the model, testing is also over. Now I want to predict the number or digit for the given image. So here for that we have to pre-process the image. Whatever you have given the model input, thus in the same format you have to pre-process the new image also. For that I am defining one model, one method, that is image pre-process of. So image equal to image open. So whatever you have given in the load images method, whatever you have given the steps, the same steps you have to provide here also. You need not go for the labels because it is the new image only. There is no label. You have to predict the label. So image related steps we have to include. So here we are giving this, and then return the image after converting into NumPy array, and then you have to provide that into one image only, so that you have to reshape it to one, and then see here I have given one image. Image size may be 32 by 32 or something, but it is converted into one dimension array, and this value, this record should be given to the model, so that I am just displaying. See here, I am just displaying the image. This is 3. It is showing 3. So the output should be, our expected output is 3. So 3 we have to get. For that we are using the model.predict of image, and it is the softmax we are using. So we have to go for the argmax, meaning that which is having the highest probability out of 6 that we are giving. So if you execute this, we should get 3. So the output is 3. So in this way we can build the models and train them from the scratch by using the Keras library, TensorFlow and Keras library. So we can handle the image analysis by using the logistic regression and also by using the ANN. Thank you.